I will be talking about IPLD. IPLD is the Interplanetary Link Data System, and that's the underlying data structure we use for IPFS and a lot of other projects. So what is it? It's the decentralized permanent memory for a decentralized permanent web. That's what I like to think about it as. If you, in a decentralized web, you need some way of talking about data. The IP in IPLD stands for interplanetary. We call it interplanetary because, you have different needs when you want to make things at an interplanetary scale. Latency becomes insane, and bandwidth becomes a bit of an issue. Sorry, I'm getting a bit of feedback. I can step back here, I guess. Okay, so yeah, the main thing is you need latency tolerance, and you need to work in a semi-connected or a disconnected network. But this is actually also a problem at the planetary scale, where even at the planetary scale, not everyone has a fast internet connection or a reliable internet connection. Finally, why? Well, we made it because we needed it for IPFS. So we needed it for the interplanetary file system. Really, we needed some form of inode or block system. But if you look at an inode or a block, it's just like inodes point to inodes point to blocks. So at the end of the day, we needed an interplanetary DAG. It's some directed acyclic DAG or graph. So how did we do this? Well, first of all, we needed some way of dealing with latency and deduplication for dealing with bad networks. So we use something called content addressing that you're probably all aware of. Basically, with content addressing, you have some globally unique and globally verifiable name for data. Currently, we use cryptographic hashes because they have these properties. However, you can use other schemes because cryptographic hashes actually have additional properties you don't necessarily need. Also, just warnings for cryptographers so they don't beat me up. So first, we started out with what we called the Merkle DAG. The Merkle DAG is a minimal Merkle-linked data or directed acyclic graph. Basically, in this system, you would have objects that have, I'll show you the next slide, a data field and a links field, where the data just includes a blob binary data, and links just point to other objects. This is what a data structure would look like in this Merkle DAG. There, I'm using JSON for my data, but in IPFS, we just use raw binary, and it's going to be really painful to work with because you have to know what the data is and then deserialize it, which means you actually deserialize twice. You deserialize the Merkle DAG object, and then you deserialize the IPFS object. Also, the data section can't point to anything because only links can. So you have a separate section of links pointing to various things. And it gets kind of messy to deal with. But that's basically what a Merkle DAG node would look like. So then we decided, no, we need something more general. So we came up with IPLD. IPLD is structured, so the entire data structure is structured. You're not just limited to this data section and link section. The entire data structure is self-describing. So you can see the schema that's built into the object. So you don't need external schemas. It's versioned, so the pointers or the content addresses we use in IPLD have a version attached to them, so we can upgrade that to upgrade the entire system. The current version is not, which is painful. Or sorry, the old version, the protobuf was not, so it was painful to deal with. It has path traversal, so you can say /IPLD / some address of some content / path through the object and actually drill down to some data, so it makes it easy to work with. And it's also it allows us to make an internet of data. Basically, this allows us to point to get objects or Ethereum objects or whatever by just saying in the pointer itself, we say what the data type is, and it tells you how to decode it. So we can actually point to get commits from IPLD and even explore get trees in IPLD and transmit get objects over IPFS. It's really quite cool. And I suggest you check it out. So the key part here is the self-describing content identifier. This is what we call CID. And the components are, it has a version, the IPLD format tells you how to understand the data, and then a hash, which tells you where the data is. It's a content address. An object in IPLD would look something like this. It just has fields, and company there is actually a pointer to a different object. For example, you can actually, I was talking about pathing, you can actually resolve a path like this, where you path through /IPLD / some content identifier / company / name, and get back protocol labs. So that's how that works. We don't need to go into the details of how CIDs work. Team, you can look at the slides later. And status, we have basic deployments of IPFS, CRDTs, Git. We're working on new formats, like Ethereum, etc., user friendliness, and more CRDTs. And the next talk will actually be about research, so I won't cover that now. Where's David?